Hi everyone! Today we are going to be demoing our final project for ECE420. For this project, we created an Android app that uses a FLIR-1 thermal camera to capture thermal images and detect whether or not a human is present. To perform the human detection, we implemented the system shown in this block diagram. Processing begins when the user presses the Capture Image button. Upon receiving the input image, some pre-processing steps are taken. These steps are shown in the purple boxes. First, the image is thresholded to create a black and white image. And then search regions are determined by only considering the white or warm regions of the image, since in most situations humans are warmer than their surroundings. Once we have determined the search regions, we then take the original image and begin the human detection process. We use the histogram of oriented gradients, or HOG, technique. The steps of this algorithm are represented by the teal boxes. First, we compute the image gradient for each pixel in the image, and then we create histograms binned by the angle of this gradient. Finally, we create a feature vector by block normalizing our histograms. In the training stage, shown in blue, many feature vectors can be given to a support vector machine, or SVM, that will develop classification weights W and B. Then, these weights can be used to evaluate an arbitrary input image to determine if a human is present or not.
We begin by connecting the FLIR-1 thermal camera. When the app is first opened, the feed from the camera will be displayed in this box. The color palette of the camera feed can be changed using this drop-down menu. There are 5 different options. Once an image is taken, annotations about the scores and whether or not a human is present will be overlaid on the image. The color of these annotations can be selected using this slider. We can then take an image by pressing the Capture button below. These annotations on the image can be turned on and off using this switch here. You can see here the annotation in yellow saying Not Human Detected. Once an image is taken, it will be displayed and 2 options will appear. The option on the left, Save Image, will save the image to the table Photos. The option on the right, Resume, will discard the image and allow the user to take images once more. At the bottom of the screen, we have a receiver operating curve, which allows the user to select the threshold that divides humans and non-humans. This curve was generated by looking at the detection characteristics, the probability of detection and probability of false alarm of the system for various threshold values. The user can select this threshold by tapping on the plot. Notice that the parameters corresponding to the selected point are displayed on the right. The user can also select the number of humans to detect here. This control exists because of the limited pixel resolution of the thermal camera. Now let's take a picture of a person and make sure we have selected to detect 1 human. As you can see, the person was detected. We can see the score, which is 2.75, and the box indicating where the human was located. Finally, the Calibrate button calibrates the camera to remove effects of the sensor heating up as it is used. The Gallery button will take the user to look at the various images they have saved. And here is the image we just have taken. And this is our app. Thanks for watching.